Okay, so today we're going through SQL for this study group, but before we get started, I wanted to talk about some upcoming events this next week. So reminder that Monday is a holiday, so there will be, well, we don't usually meet on Mondays anyways, but there will be no instructor support on Monday on Slack. So if you have questions, though, I do encourage you all to post them on Slack. You can help each other out. But hopefully there's not too much work to do this long weekend. Don't forget that your cumulative lab projects, please send them to me on Slack. Send them to me on Slack latest by the end of the weekend. I know that some of you are working on it. I've already received a couple of yours, so thank you. And if you don't finish every single question, it's no big deal. I really just want to get a sense of how you're coding and how you're thinking about solving these problems. Cool. So just as a preview for next week, the first study group next week, I'm actually going to introduce the end of phase project. So earlier that morning, I will send out your project pair so you can connect with your project partner prior to that study group. So I'll be introducing the project then. That evening, just so happens to really work out that my other cohort is presenting that phase 1 project. So I put the event over here. If any of you want to just see what the end product of that project looks like, you can take a look there. Also want to highlight there is an alumni Q&A. So these Q&A events happen once, sometimes twice a month. And really, really cool. On Wednesday, we have a former DS graduate who now works at Spotify. I personally don't know this student, but their backstory is super interesting. They actually had graduated, I think, 2+ years ago and slowly worked their way up at Spotify, starting with I think, let's see, someone told me that they started as a business analyst to slowly become a data scientist through promotions since graduating. So could be a very, very similar career path to what some of you might be doing. And he works at Spotify, so that's cool. So that's what we're looking forward to next week. Questions about any of that stuff? All right, well, the project is actually already published at the bottom of, let me go to student view so it looks like what you see. The project's already out here. If you scroll down to the bottom and you go to milestones, you'll see the phase 1 project is already here for you to read if you just want to read into it over the weekend. Feel free to do that, although no pressure to at all. You all do have a little bit extra time to work on it too. For those of you who want to prepare, the main bulk of this project will be pandas as well as visualization. So it's mainly doing pandas as well as visualizations. So based on that, all of the material from today and next week, I would deprioritize that just for the project. So today we're talking about SQL. Next week, we'll be talking about other database types as well as how you can grab data from the internet. Those things you can choose to incorporate in your project if you want, but you don't have to. It's not a necessity at all. When we get to those topics, I'll talk about how you might be able to incorporate these things, but I am not expecting that at all from any of you. So just for some context, that's what it's going to look like. Yeah, so I will be sending out your phase 1 project pairs on Tuesday morning. So look out for those. Any questions about that so far before we dive into material? All right, so let's talk about SQL. A lot to go through here. So with SQL, we're dealing with a database type. So SQL stands for Structured Query Language. And the kind of data that you'll be working with SQL is relational data. So let's talk about some definitions first. What is a database? A database stores sets of data that can be queried for use in other applications. There are also database management systems that can support the ease of use of databases. So the two main kinds of databases that we'll be talking about this phase are SQL databases and NoSQL databases. SQL databases are basically anything in a table format. NoSQL looks more like nested dictionaries. We'll get into NoSQL at the start of next week. So specifically, what is a relational database? Relational databases, again, are things that are in tables, and many tables can be related. You can have relational database management systems, RDBMS. We're not going to be using any of these relational database management systems, but good to know that there are third-party softwares out there that make it easier for us to work with databases. But yeah, relational databases are row-based table structures that basically connect related data elements and includes functions that maintain security, accuracy, integrity, consistency of data. So the processes that we will be talking about with regards to databases today and also on Wednesday are the Crud processes. Crud is a very commonly used term whenever you're dealing with any sort of database. It just refers to the four main processes used: create, read, update, and delete. I will say that for our role as data scientists, we mainly just need to read the data. Usually someone else, like a data engineer or whoever's managing like a database administrator, they are the ones in charge of doing like the creating and the updating and the deleting of data. And we pretty much only deal with the read aspect. So for SQL, and for today's session, we're only really going to talk about different ways that you query data. On Wednesday's session, we're dealing with a different database type known as MongoDB. It's a completely different looking kind of data, and we'll talk about the CRUD processes with regards to that next week. So what is SQL? You can call it SQL or SQL. It goes both ways. I like saying SQL because it's fewer syllables. Stands for Structured Query Language. It is a different programming language. So it is, Python is its own programming language. SQL is its own programming language, and it's basically used to communicate with data stored in relational databases. So SQL syntax is similar to English, which makes it relatively easy to write, read, and interpret. Some really neat things about SQL: they are not case sensitive, which is always nice. And also, you don't have to do like new lines all the time, if that makes sense. Like you can actually write all of your queries all in one line, and that'll also work. So those are two neat things about SQL. And the way that we use SQL, it really depends on how your company in the future sets it up. But for our purposes, we are actually going to connect to a SQL database through Python, through our Jupyter notebook. And I'll show you all, and I'll explain what these little extra bits of code do. But before that, with every kind of database, and we kind of talked about this with regards to our JSON files from last week, every kind of database and every SQL database should come with a schema. Any well-maintained, well-documented database should come with a schema. And this is an example of what a schema looks like. This is, I think, from one of the labs. So it basically shows all of the different tables that exist within the database. So database can contain multiple tables. And the schema also shows you, what are all the column names and column data types within each table, as well as maybe how some of them connect with each other. So this is probably something to do with like, I think an office's employees and departments and stuff like that. You can sort of see that there is this employee data table here that is kind of related to like department employees and like job titles and like their salaries. So they're all somewhat connected. These lines over here, what this means, these define the relationships between the data tables. Not super important to know, but basically when you see that it like branches out, there's a many relationship there. And I do have a section talking about relationships in a little bit. But the whole idea is that one employee can have multiple salaries. So one to many means that one employee can have multiple salaries, and you can sort of infer from this that, it looks like there's a to date and from date. So maybe every time an employee gets raised, there's a new row in this specific salary data table. So that's kind of what these connecting lines all mean. There are different ways of representing these lines, but for the most part, if you see like one that stems from like one branch to like multiple branches, that one branch is the one relationship, and then the multiple is the many. So there are many different ways that you might see these in different schemas, but for the most part, if you're interested in reading, if you're interested in interpreting this, that's how you'd interpret it. So every every SQL database that is well maintained and well documented should come with a schema. So I think in all of our labs that we're dealing with databases, there is some form of a schema like this that tells you what column names there are, data types, as well as to some degree like relationships. All right, so cool. Down to relationships. There are three main kinds of relationships within any relational data. The names of them are one-to-one, one-to-many, and many-to-many. So one-to-one, pretty straightforward. That just basically means that one customer has one address. So an example, I wonder if there's an example in this. So actually none of these are one-to-one relationships, but let's just say you had another table. Let's see, you have employee information here. You have employees' birth date, name, gender, hire date. Let's say you just have like another table of zip codes that they live in. Every employee, if this is the way that they store the data, every employee will be associated with one single zip code. That is a one-to-one relationship. If that zip code table also contains information about employees' past zip codes, then it becomes a one-to-many relationship, which is the next one, one-to-many relationship. Most commonly, if you have a bunch of customers and a bunch of orders, one customer usually makes one or more or no orders. So therefore, there's this one-to-many relationship where multiple orders can be attributed to one customer. I do think that for these relationships, it's easier to think about it in the context of your database and in the context of the data that you're given. So yeah, one customer with many orders, one-to-many. Finally, you also have the many-to-many relationship. Like, let's say you have an inventory of different items, and then you have different orders that are being placed. One order can have multiple items, and one item can be in multiple orders. So therefore, you have this many-to-many relationship. There's actually an example in the schema, but I wanted to talk about this first. Typically, when you have a many-to-many relationship with orders and items where one order can have many items, one item can belong to many orders, there is usually an extra table that tracks this relationship. So imagine if you have order numbers 1 through 20 and you have items 1 through 5. The most efficient way to store information about what order and what items go together is actually in a third table where you have pairs of orders and items to just document that information. So it's not uncommon to see if you have a many-to-many relationship that there is usually a third table. The example here is departments and employees. So departments can have multiple employees, and employees can belong to multiple departments, I guess, in this company. So you can sort of see here that there is this middle table known as, here, I guess they call it department employee table. Let me zoom in a little bit so it's a little clearer. You can see that the data that's stored in this table, it's just employee number, department number, from date to date. It doesn't have information about the employees, doesn't have additional information about the departments. This is known as a junction table. That's one of the names. I forget what some of the other names are currently at this moment, but this is just a table that helps to store the relationships between departments and employees in a slightly more efficient way. So therefore, between departments and employees is actually a many-to-many relationship, but when you're storing the data, it is two one-to-many relationships. So it's not very common that you see like a many-to-many relationship through a schema, but through this middle table, departments and employees do have a many-to-many relationship. So even though there's only like two, I guess, entities that you're joining up, you might have to like join 3 tables together. So that's getting very into database theory, which is not what we're focusing on right now. But just in case you find that there's this random table that has kind of some information, but no information about the departments or the employees themselves, that's the reason why. All right, questions at this point? All right, with SQL, there are a bunch of data types. This is also a good place to mention that there are actually different kinds of SQL. You might call them different flavors of SQL. And so the SQL that we'll be using within Python, and there are actually two main kinds of SQL used within Python. We're going to be using a SQL known as SQLite 3 to be specific. You might come across different kinds of SQL known as like MySQL. MySQL is the other very popular one that you can work with Python. There's also PostgreSQL, if anyone's heard of it. I think Oracle has their own SQL as well. There are many different kinds of SQL. So if I even look up like kinds of SQL, there we go. There's many different kinds of SQL. So let's see, PostgreSQL, MySQL, SQLite, SQL Server. So they're just different kinds of SQL. For each of these SQLs, and I will say when you're interviewing for jobs with SQL, it doesn't matter. They're usually pretty language agnostic because the differences between each SQL, they exist, but are quite subtle. So it's usually just a matter of like, okay, instead of saying a specific keyword is a different keyword. So as you're learning more about SQL, and if you encounter, these different flavors of SQL as you're, practicing or working through this stuff, that's what that is. There are just different flavors of SQL that exist. If you know one, it's very easy to adjust to the others. Like I've done projects in like 3 different kinds of SQL at this point. And yes, I do have to end up Googling, okay, I'm very used to MySQL. What's the Postgres version of doing this? Which there's a lot of that translation online on like a bunch of different online resources. So that's a good thing to know. Because the flavors of SQL are different, the naming of the data types can also be slightly different, but there are some of the very broad main data types that persist through all of them. So there's always our numeric ones. So there's going to be integers and floats. You might see some of them be called, instead of float, they might call it decimal, but they're kind of interchangeable. They're just different flavors of SQL using different terminology. There's our date time. Date time is something that I think within pandas is also pretty similar. Instead of string or object like we've seen before, if it's a string within SQL, they usually call it either varchar, which stands for variable characters, or text. So if you see that, that's what that is. This is less common. You might see binary like true falses, like booleans. And there's also a bunch of others. So as an example, sometimes within a SQL cell, you might have a JSON file format or a JSON data type format. Blob basically stands for really long chunks of text. So yeah, usually if you encounter something that is not familiar, you just have to look it up and they'll tell you how you deal with it. So data types are slightly inconsistent in terms of the word used across different SQL flavors. So yeah, usually they are used pretty interchangeably between the SQL flavors, especially if you're just talking about it to someone else. Okay, so let's talk about SQL within Python. We're going to use this extremely simple database. It is a Pokemon database. If anyone's not familiar, it is a game where you have these little characters and they have powers and types. So that's what this is. The way that you connect to a database, and let me show you all. I actually have this database here. So this database is also in the study group repo. If you look into the database, what's unfortunate is they're pretty opaque. You can't really see a SQL database, not like, how when we were looking at CSVs, you could actually see some of the values show up. Same for JSON. But for SQL, we can't see it because they're actually storing the data in a much more efficient way, such that we are not able to read it, but trust that the data is there. Okay, so we're dealing with that database, and this is the schema for that. So I'll show you all the tables in a little bit. The schema exists here. We'll be referring back to the schema as we work through some queries. But talking about how Python connects with SQL. So Python connects with SQL through what's called a cursor. It's usually called a cursor. Other words for it, you might see connection. You might see CNX, which I think here, connection, that's what CNX stands for. You might see CONN, that's also a connection. And the way that SQL and Python work together is your Python is sort of creating a cursor to interact with SQL. So in some cases, you are working with like a database management system and you can directly just type in the SQL query like these select statements. These are SQL queries. Through some third-party software, you might be able to just type those straight away and get your data then. But through Python, we got to use this special syntax, and I'll break that down in a little bit more. But basically, there are several different ways to do this. This is one of them, is you use SQLite 3's connection, this cursor connection. And all you have to do is just feed in the database name, kind of similar to how you do like a read CSV, feed in the database name to connect to the database, and you have this connection set up. Now, this connection doesn't really mean anything. It's just setting up the link between your Jupyter notebook and the SQL database. So here, if I were to like output connection, it's just saying that there is a connection. All right. To read SQL, there are a couple different ways to do this. I think if you look at your labs, they show a different method that does like a something cursor.fetchAll. That works as well. The main thing that you want to take away from this section is really how you build these queries. So whereas in your curriculum, they talk about a way to do that through, I want to say it's like cursor.connect. You feed it in like a triple quote query. It's pretty much doing the same thing. And then that one, you actually have to feed it into a pandas data frame to turn it into have it like, display your results. Pandas has a built-in read SQL method where I have this read SQL method here, and it is able to take in a query as its first parameter, and then also take in the connection, and it will output whatever the result is of your query as a pandas data frame just straight away. Doesn't matter which one you use. I personally like this one because I think it's fewer lines, but it really doesn't matter. One important note on syntax for this is use double quotes when you're quoting strings within your query, and then wrap the entire query in single quotes. This took me a good amount of time to figure out that this was the issue, and I'll have an example later on to show that. But just as a quick example, there are 3 tables in this database. Let's just see what they look like. So we have a Pokemon table, a types table, and then a Pokemon types junction table. That's because Pokemon and types has a many-to-many relationship. So therefore, to store it more efficiently, we have this Pokemon types table in the middle. And we'll just inspect to see what this data looks like. So the most basic thing you can do in a query is just return an entire table. And the way you do that is select star from whatever the table is. SQL is also not case sensitive, so it doesn't matter. Usually by default, you should form the habit of capitalizing your keywords and then also having the case of your data tables or your column names at least match what is given in the schema, but it's actually not case sensitive. So let's run this and take a look. So just like this, we have the result of one table already as a pandas data frame. So pretty sweet. You can see that these are actually the names of like 151 existing Pokemon, their experience points, their weight and height. So pretty basic. This is the information that we have. If you want to take a look at some of the other tables like Pokemon types, or let's just look at types first. If you look at types, basically for context, every Pokemon has like a type. So if there's like a fiery looking dude, it will be a fire type Pokemon. So something like that. So there are all these, there's like what, 18 unique types that a Pokemon can be attributed to. And also one Pokemon can have multiple types. So that's why we have this many-to-many relationship. If we take a look at that third table in the middle, you can see that we have Pokemon ID and type ID. So that means Pokemon ID 1 has type 12 and type 4. Pokemon number 149 has type 16 and type 3 associated with it. So you can see how that this is a pretty efficient way of storing this many-to-many relationship. If I were to store the multiple types information in this table, you can imagine, okay, maybe I have like a type column, but maybe I have to put like 2 types in a single field, or have multiple rows for one entry here. So because of the many-to-many relationship, it's more efficient to store it in that other junction table. So this is the most basic query. If you just want to return an entire table, you just select star from table name. Cool. So let's build up our queries. So there are many different parts to a SQL query. Basically, the idea is how data scientists work with SQL is you basically want to query the relevant data that you need for your analysis. Sometimes you can do very, very basic level analysis through SQL. Actually, you can do a lot of analysis through SQL, but that's for programmers who purely work in SQL. You can actually write functions in SQL as well, but most data scientists who work primarily in Python don't have to do that, just so you all know. But yeah, these are some of the main things that you need to do with SQL. I will say that from my experience and other students' experience, the level of SQL that you get to in your curriculum in the labs is pretty much the max level that you will get in interviews. So yeah. All right, so let's do a couple questions. So I have a couple prompts here just to do different queries. So to start, we did this already. If you want to select everything, you just select star from table name. And what I'm doing here is I'm just replacing the query here. I'm saving the query as a string, replacing that, and that returns my whole table there. Cool. It's pretty straightforward. Let's do the next one. Select all the rows from Pokemon types table. So a lot of times in a SQL query, they tell you which table they want you to get information from. So it says here, select it from the Pokemon types table where the type ID is 3. So you're sort of filtering, very similar to what we were doing with pandas, but I actually think it's a little bit simpler. I don't know, people have different preferences on syntax, but here the keyword that we're bringing in to subset or filter based on a condition is the where keyword. So the where keyword, you just do where type ID is equal to 3. SQL does not do the double equal sign because you're not really assigning anything in SQL. So you just do the single equal sign here. And because remember that Pokemon types table is just only the IDs of either. So here we can see that we have these, 19 Pokemon that have the type ID of 3. So this is how you do a filter type ID equals 3. You can also do multiple conditions. You can do where type ID equals to 3 and maybe Pokemon ID equals to, I don't know, I see 6. So you can do that as well. You can stack your different filters, filter conditions. So, but yeah, the question asked for this. So we have this. So this is how you filter with a where clause. Cool, let's take a look at the next one. Find all rows from the Pokemon types table where the associated type is water. Okay, so a little bit trickier. We know that in this Pokemon types table, they give you the type ID, but they don't tell you what the type name is. So in order to get the water information, we have to associate the two tables with each other. So when you have to put two tables together, we use a join. Pretty similar to what we were doing with pandas, we got to use a join. Also, as I mentioned before, for SQL, you can have everything all in one long string in one single line, but sometimes that can be hard to read, especially when you're constrained by the width of your screen. Another neat trick, if you want to do multiple rows with anything on Python, actually, you put a backslash. So I'm just going to do a bunch of backslashes to make it a little bit clearer what we're doing. And this will also work. So, and this also brings to question the other syntax thing I was talking about. If I'm referencing a string within my within like a condition or something, I'm wrapping the string in double quotes, and then the main outside is going to be single quotes. And then this just allows me to break my string into multiple lines.
Question.
Mm-hmm.
Quick question. Is this where that whole breaking in front of the function and then indenting so that they line up comes into play? So that where like industry standard, like when you look at solutions, it kind of does that. Is that kind of an industry standard where it's just to make it easier to read code, where you would say where you have like select, you would break it in front of from, and then line it up with select so that it all looks, so that you can run through the list of the functions. And
yeah,
then it looks
I get what
cleaner.
you mean. Yeah, you could technically do something like this where it just looks a little bit cleaner, and of course you can like align everything. I will say not so much an industry standard, but I will say for data science, because a lot of what we're doing is analysis and that happens behind the scenes, unless your analysis is going to be reused for maybe like multiple different purposes, and sure, the formatting matters. But actually for data science, a lot of the code is just for ourselves. So therefore, I would say the only thing where the formatting or like the way that you phrase certain things or coding methods matter is very company specific. So actually within companies, when you start, a lot of companies will give you a style guide on how they want your code to be formatted.
Okay.
One of the industry standard things is actually on that note, like, I forget what the character number is, but there is a standard of like within one single line, there should not be more than a certain number of characters in your code. And so that's when you should break it up like this. I forget what the number is though. I
Okay,
think,
because
yeah,
I know in Visual Studio they have an option to limit the number of characters per line. Does
yeah.
that also help to when you're trying to work through it, just to keep your functions on different lines so that you kind of know what's happening? Because I know I get lost sometimes in big long lines when I can't
Yeah.
see everything.
Yeah, I would say, yeah, I think that
And
that becomes more personal and it depends on like how you view your own code. Am I actually prefer coding with everything on a single line because that's, I don't know why. But yeah, yeah, absolutely. I think when it comes to like your code on a page or in a cell, that's like really up to you, especially for data science where your code is for your own analysis or for analysis within like a smaller team.
okay, and then if you break them that way, do you need the slashes to separate since you're doing it on
Yes.
different lines?
Yes, you absolutely. If you don't have the slashes here, first of all, this they won't recognize as a string, and you'll get syntax errors. And then if you have the slashes there, it'll work. So
Okay,
the
so that
slashes
just
is what tell it
designates
to, yeah,
the slash. It recognizes it's one line, but you're really visually breaking it into different ones.
that's right. Yep.
So it's kind of like when you're doing HTML, you break it, you put a placeholder as a line break. There's a
Yes.
code that line breaks so that when it reads it as a line, it reads it as one line of code, but you've broken it into lines, so it ignores
Yeah.
that.
Yeah. Like in a string, when you have like the backslash n, when you have like, just gonna quickly do this. If I have like backslash n, it prints a new line, and then I think it's, yeah, this should work. So just as a quick example, this just
Okay.
means like enter. So yeah, similar.
Okay. Okay.
Mhm.
But this
Cool.
is
Um,
only for SQL, right? This is not for Python. We don't need those lines in Python.
Well, these lines actually also work in Python. So the reason why this line works is because you're reading a Python string. And so, yeah, in Python, if you have a really long string that you want to break up, or if you have like a long function with maybe like a
Right.
lot of
Okay. So
conditions,
only
you
for
can do
strings.
this.
I got it. Yeah. Okay.
You can actually do this not just for strings. Any code, let's say you're writing something with like multiple conditions, maybe you're stacking 3 conditions together and it looks like really long on the page, you can actually use a backslash to tell it that, okay, we're going to continue on the next line.
Right. No, but what I meant is a lot of times, like I've never really needed the backslash in Python. Like as long as
Yeah,
it's not in a string, like as long as you hit enter, it will still recognize that it's part of like a function. For example, if you're writing a long function.
that's right. Yeah.
so in SQL, essentially, rather than having like select and then parentheses to dictate it's a function, you don't need that.
Yeah.
And then your function itself, rather than having to wrap the quotes act as the wrapper, essentially, rather than having brackets or parentheses around that individual function. And
Yes.
then
I was, mhm.
when you hit another command like join or where, it's equivalent to, you just get to leave out the period.
Yeah, pretty
It
much.
just
Yeah.
recognizes that that's a new function because that, okay.
I will say like this
The,
entire thing is a query. It doesn't matter. Like the way that SQL compiles your query and understands your query is literally just by looking for these keywords within a single statement. So it's not so much like there are different parts that are broken up. If you have a bunch of keywords that don't work properly together, SQL will just throw you an error saying that like, I don't know what's going on here. So these are not, I feel like it is helpful to think of them as separate components within a query, but in the backend, SQL is not doing it that way.
Okay, but those do the query keywords have to be in capitals, or do those?
Not necessary, because
But
SQL
it's
is
just
not case sensitive. Yeah.
okay. So, but it's just easier to see, as it's easier to keep all of your columns and things in lowercase, and then your keywords in upper, just so it's easier to see what's what.
Yeah, more specifically, keywords in all caps, and then column names or table names matching whatever the schema says. So if the schema has it as like capitalized, then I would say you should capitalize it as well so that it matches. But yeah, as long as it
Would you
matches the
use
schema.
opposite, just as best practice, would you use opposite case just to make it easier for you to differentiate visually between column names and keyword query keywords?
I will say that as a data scientist, you don't have control over the schema. So therefore, yes, I think in most cases, column names and table names are in lowercase, but at the core of it, you don't have much control over that.
Yeah, but say for instance, the schema was in all capitals.
Oh,
since it's not
okay.
case sensitive, would you reverse that and opposite the case to?
I think that becomes more of like depending on who's reading your code, I would say that it is a good practice to match the schema over clarity of your query.
Yeah, well, when you personal decision when you're just writing the initial, because then you can always go back and depending on your style guide, reformat that.
Yeah.
Especially if you're not working in a notebook, you can just do find and replace for things, correct?
That's true. Yeah, absolutely. That's right. Yeah, I would say it's very, that part is up to you because it's not case sensitive. Yeah.
Okay.
Awesome.
Real quick, is there a certain reason why you would use the backslash over like the 3 double quotes, or is that just personal preference?
So the 3 double quotes is specifically for the other method of connecting to SQL. So that other method is the cursor.fetchAll. Actually, I can pull it up since I think we're pretty good on time. So I think in SQL, let's see. Hopefully this loads fairly quickly. Let's go to solution. Yeah, so they use this separate method of, they use read SQL now too. Okay, cool. But there's another method that you actually do like a something.fetchAll. So hold on, let me see, Python SQL.fetchAll. I forget what the library is called when you do that. Okay, but this is just a quick example. Another way of doing it is you can do it like this and you do cursor.execute. You might come across this in some of the solutions, I think. If you've never seen this before, then don't worry about it. But yeah, for this specific kind of querying your SQL through Python, you have to do it with the triple quotes. And then for this method, what I'm using, pandas read SQL, it's single quotes. I think it shouldn't make a difference in this case. I don't remember. Let's find out. Let's do the triple quotes here. And then triple quotes here. I think it should be okay. Yeah, it works too. But I know for the other method, if you're doing anything with like a fetch all, that one has to be in triple quotes.
Okay, so rather than using a dot fetch all, the triple quotes kind of act as a fetch all.
Not exactly. The difference is that this is a completely different method.
Okay.
Yeah.
Okay, so since you're using a cursor execute, you have to put 3. That's how syntax wise, cursor execute reads that particular query, and then you fetch all and that. Otherwise, it won't work with just a single. Okay. So that's just simple syntax. Okay.
Yeah, that's right. And anything with a triple quotes is actually called a doc string. That's the name of anything within triple quotes. So cursor.execute takes in doc strings, whereas I guess the read SQL method can take in either a string or a doc string.
Okay, so triple quotes basically tells your later code that that's a doc string.
Yeah, and the benefit of go ahead.
So it's equivalent to when you do curly brackets, it's always a dictionary.
Yes.
brackets are always a list. It's just a way of the code reading a specific type, like a marker that tells
That's
it,
right.
that tells the
Yeah.
code. Okay.
And the benefit of doing a docstring is you don't have to put those backslashes. So this
Okay.
will also work. So
Okay, because it reads
pros
it
and
as
cons.
one. Okay, because in a docstring it would read all of that as one consistent function string, essentially. So it doesn't matter what context, it's just one law. It's all. When you do large, or when you have a large list of ors and things,
Mhm.
you would just put one bracket and then you could return, and doesn't matter how many returns you put in, it always reads that as one list
Yeah, I think so.
in base Python. Okay.
Yeah.
Okay. All right.
Cool. Awesome. Yeah, great clarifications, everybody. But this query, we want to talk about joins. Yes. So back to this, we are looking for all the rows from the Pokemon types table where associated type is water. So earlier we could get that, okay, this particular type ID of 3, one way we can do it is we can query that first table and figure out which number is water, but we don't want to do this in 2 queries, but we can do this in 1. So what we're doing here, and there's a couple notes on Sql querying syntax here. We're going to join over the types table. So if we don't remember, the types table looks like this. And we're joining this types table so that we can figure out which one is water. And water happens to be number 11. So we're not going to use that within our query, but we're joining the 2 tables together. So here we're joining the types on types.id equal to Pokemon types.typeid. So be very, very aware here that the syntax here, you have to tell it which table, which column matches which table, which column. So in this case, we want to match up the type ID column from Pokemon types with the ID column from types. So that's how we're joining it together. And then where types.name equals to water. So whenever you have multiple tables in a query, whenever you're joining more than one table together in a query, and you can join as many tables as you want, sometimes you run into column name ambiguity. Sometimes you can have column names in different tables that are the same, but refer to different things. So a good practice is when you're referring to a specific column in a table, that you tell it which table you're talking about. Because here you see types.name equal to water. If I just did name equals to water, see how in, not in this example, but in, let me just change it back. But in Pokemon, there is another name column. So you could run into some ambiguity there. So it's always a good idea to do types.name or do table name dot column name just for clarity. So what we've done here is we're doing the join followed by a where clause to just filter out the only water Pokemon. One more thing, like I mentioned before, we're doing table name dot column name. Here we can do all the rows from Pokemon types table. So now this is interesting. We do Pokemon types dot star. So Pokemon types dot star just returns all of the columns in the Pokemon types table. So here we have, our 2 ID columns. But if I just did star, it'll look different, because star is going to return us all the columns from all the tables that we've joined together. Therefore, we have, we have this kind of redundant column as well. But we also have the name here. So depending on what you want to be returned to you as part of your query, you can define that in here. So maybe you want to do select, let's see, Pokemon types dot Pokemon ID. And if you want to select multiple columns, you can do types dot name, and that works. And you can keep stringing it together with commas. So that's when, making more lines will be more helpful. All right, let's talk about this next one. So this next one deals with group bys. So what we're doing here is we're going to find the average weight for each type. And then order results from highest weight to lowest weight, and then display the type name next to the average weight. So there's quite a few things going on here. So what we're doing first is an aggregation. Very, very similar to what we talked about with pandas. We want to find the average weight for each type. Therefore, if you're thinking group by, that's what we're going to do. Different from a group by, where in pandas, when we did a group by, we did group by what column and then did our aggregation afterwards. Because of the structure of SQL, you can actually do your aggregation at the very, very start. So the way that SQL does reads your query, it actually reads everything else first and then goes back to see, okay, based on everything that was done, what do I want to select out of it? So let me quickly make this into multiple lines so that it'll be easier to see what things are going on here. Okay. So first we are selecting the average weight and the type name because this is what they want us to display. The type name next to the average weight. So that will be what we're selecting. However, to get to what we want to select, we got to do a couple different things. First of all, we have to join the Pokemon types and the types all together. We basically want to use all three of these tables because we need the name from here and we need the types from here. So therefore, we got to just join all of these together. There are different kinds of joins. I did talk about joins when we talk about pandas. The inner, outer, left, right work the same in SQL as well. So in this case, I figured inner join gives us what we need. And this is honestly through trial and error, or if you want to think about the theory, that also works as well. But I'm joining my two tables to my base table, which is Pokemon. So first, I'm going to join the Pokemon types table because there's that one-to-many relationship there. So I'm joining it based on this. Pokemon ID equals to Pokemon.id. I'm also going to join my types table with the very, very similar syntax. And then I'm grouping by types.name because I'm grouping by the type. You don't have to necessarily group by types.name. You can also group by type ID because type and the type name and the type ID are, they always match up. So you can just pick one to group by over. And then we are sorting it because here it says display the type name next to the average weight and then order from highest to lowest weight. So to just sort your table values, you just throw in an order by the average of the weight, which is right here, descending. So let's run this. Oh no, did I forget a backslash? Oh, cannot have these multiple lines. There we go. Awesome. So here we have our average weight, and then we can see which type is the heaviest. I also want to use this to talk about aliasing. You can also alias your column names. So for example, here, average weight, sure, it is indicative of what it is, but you can also alias your column names very simply just by doing as average weight as an example. And that changes the column name. So if you ever see like an as, that basically aliases your column name, just so you don't want to see if you don't want to see like that aggregation syntax appear, that's how you do that. Questions?
So that's the equivalent to the select from, oh, Mike keeps telling me my internet connection is unstable. I think it's because of my Bluetooth earphones. But
Good.
so select from is kind of the equivalent in base Python of doing for in, a for like X in when you're calling that particular column. And then you aggregate, instead of using .agg, you just aggregate, you just sort everything through just essentially English language without a lot of periods.
Yeah, kind of. Yeah, you can think of it that way. Yeah, because all of this puts all of the columns together, right? If I just selected, well, as long as you have a group by, they will tell you that you have to have an aggregation. So if I were to do like select star from Pokemon, sure. Oh, okay, that worked, but the information is not exactly correct yet.
Okay, so that's like, that would be, so kind of group by in SQL is no different than group by in pandas, where group by in pandas has to have some sort of a statistical aggregation at the end of it. You can't just do pd.group by. You have to put some mean, average, something at the end of it.
Yes, absolutely. But even in this case, you can see that this information is incorrect.
Yeah.
So
Because it doesn't know what to do, because it doesn't have a statistical application
Exactly.
at the end of it. It has, just like in regular pandas and data frame, you have to have, like when you look at the documentation, you have to have a sum at the end. You can't just do PD
That's right.
data frame dot group by with parentheses, because it won't work.
Yep.
Okay.
Yeah, lots of little nuances, but yeah.
So it's the same, but
Absolutely.
it's just different instructions essentially that you're passing.
Yeah, pretty much. Cool. All right. So next.
So then you would, if you're doing, say, a table, not a visualization, you would use the SQL visualization explanations the same way, or would you use the Panda visualizations once you read the SQL?
Visualizations.
Like if you were to make like a histogram or something, would you read the SQL and then pass it as and then use the pandas instructions for the visualization?
Yeah. So SQL doesn't have a visualization capability.
It's just a
SQL
way of
yeah.
reading. It's just a way of reading the SQL, and then you pass it on to pandas or Seaborn or Matplotlib, and then use their visualization tools to call everything.
That's correct.
Okay.
Awesome. All right, let's talk about this next one. So this next one is kind of similar, but there is a new clause I want to talk about, which is the having clause. So this one is kind of similar to the earlier one. Find names and IDs of the Pokemon that have more than one type. So Pokemon that have more than one type, what we're going to do is we're going to select and join. Here we don't need the types table because we don't need the type name. So what we're going to do is we're going to inner join this and then group by Pokemon ID, and then set a condition of having count of Pokemon ID is more than one. So let's take a look at the result first. So these are all the Pokemon that have basically more than one type associated with it. And we did that because of the count here. To just be a little bit clearer, we can do count Pokemon ID to see that all of these Pokemon have, I guess, 2 types associated with them. So from here, I want to highlight that this having works very, very similarly to where. These are 2 words that I guess in English can pretty much be used interchangeably. However, very important to note that if you are doing a condition on an aggregation after a group by, you have to use having. You cannot use where. And similar to where, you cannot use where here, you cannot use having without an aggregation. So typically, if you have a group by, you will have a having statement if you want to run a condition on the aggregation. So that's something that actually I've received that a couple times, like what's the difference between where and having? This is a pretty common interview question, and basically answer to that is having is only used when you have some sort of aggregation or group by. So good to remember that one. Okay, so that was that. Finally, let me see what's on this one. Find the ID of the type that has the most Pokemon. Display type ID next to the number of Pokemon having that type. Okay, so here, all of these things we've already talked about today, but let's just break this down again. So find the ID of the type that has the most Pokemon. Basically, sometimes in SQL, you can return singular pieces of information, right? Prior to this, we were just giving, just tables of queried information in particular forms. Sometimes you just want to get like a summary stat. You can do that here. And what we hadn't talked about is limit 1. So if you just want to find like the type ID that has the most Pokemon associated with them, pretty much you can get this from the Pokemon types because they don't care about the name of the type or the name of the Pokemon at all. We group it by type ID. we're selecting the count of that. And then if you just want to get the max, you can just find limit 1. And limit 1 basically limits how many rows you return. So if I do limit 5, you'll see that I get my top 5 types based on like how many Pokemon are associated with them. So yeah, since in this case, they just asked for the ID of the type, we can pretty much do this. And even more specifically, because they only ask for the type, we can do, select order by number of Pokemon. Oh, okay, hold on. Let me undo this. Order by count of this. There we go. And then type ID should work. There we go. So the type ID will just be 4. So sometimes you just want that value and then you're good to go. But yeah, all of these things, let's go from top to bottom. Some of the keywords that are good to remember, of course, are select from. That belongs in every single query. We have our where clause, which is a, if you want to enforce a condition on the rows that are being returned. You have our join, which puts tables together. We also have our order by and group by. So group by if you want to aggregate anything, order by if you want to sort your results, and then the having, which is where but for aggregations, and then finally we have limit. So I think those are all the main parts of SQL that are good to know. Before we end off, I want to just talk about like how we will use SQL during this course and also how you will use SQL going forward. At your jobs, you'll probably be using SQL to interact with a company's database. Therefore, very unlikely that you'll be asked to like create the database or like delete or update data in there. Your job will just be to grab the data and do your analysis. In our program, SQL pretty much stops here. I will show you all how you can incorporate SQL into your upcoming projects, but it's not a necessity. SQL is also very, very commonly asked in data science interviews. So I will be sharing, I'll throw it onto our resources page. Oh wait, I think it might be already there. Hold on, our homeroom is here. Okay, yeah, HackerRank. HackerRank is a great resource to hit SQL practice. So if you go to practice, there is SQL practice, and you have a lot of challenges available. You can filter it based on what kind of SQL queries you want to do. And what's really neat about that, you don't have to mess with the Python SQL connection. When you're doing an interview or assignment with SQL, sometimes you just have to, the important part is knowing the query. So on HackerRank, and there's a couple of other websites kind of similar as well, you will only need to type in this stuff. You don't have to worry about like the read SQL. So I highly recommend, not priority for now, but at some point, try and fit in like a little bit of SQL practice every so often, maybe a couple times a week or month. Of course, you can wrap this up as you're graduating as well. But yeah, just for added context on how we're going to be using SQL going forward. All right. Any SQL questions?
Is SQL used so frequently just because kind of like how it's easier through SQL to link multiple databases together?
Not multiple databases, but multiple tables.
To get the schema better, it's easier to have related tables that join together, and you can just put and maintain one database with a bunch of schema that are similar rather than having, say,
CSV
like an Excel
file here, there, yeah.
Yeah, kind of like how in Excel you do multiple sheets rather than multiple Excel documents.
Yeah, that's right. Yeah, exactly. SQL is also much more space and speed efficient. Querying data through a SQL database is a lot faster than filtering a pandas data frame, for example.
I would also assume it's a lot more memory efficient in terms of
it absolutely
when you're looking at the software engineers are looking at it. It's just more RAM efficient than anything, because the less lines of code you need, the less functions, the less memory that you need to allocate to different processes, I would assume.
Yeah, absolutely. That's right. Awesome. Any other questions regarding SQL?
I was just gonna say, it's also one of the oldest, which is why it's used by pretty much everyone. I think it predates Python, it predates Pandas, it predates all that stuff.
That is absolutely true as well. Yep. Yeah, SQL has been around for a while. Cool. SQL is also seen as like a what do you call it? Like a gateway coding language. I think a lot of just analysts who are not familiar with coding, SQL is usually the first thing that they pick up, just because a lot of data is already stored in SQL. It's very easy to go from, okay, rather than getting someone else who knows how to code to pull from SQL. It's been one of the roads of less resistance to coding to just learn SQL, because it's pretty easy to pick up. I think it's all about repetition and practicing to get used to SQL.
That's the opposite of object-oriented programming, where they make you suffer through C++ and
Yeah.
all of those terrible parse errors that nobody understands
Oh,
before they
yeah.
teach you real stuff.
That's right.
Real-
Yeah, we will be hitting object-oriented programming in phase 3. But yeah.
Do you make us do C++ through it, or do you use modern techniques?
No,
Because
I don't even know C++ myself.
they made it, when I did it originally, they made us do C++ in Sun Microsystems and
Okay.
Emacs. So everything was parse error. It didn't tell you what the parse error was. It just told you parse error in what line. And so you had to look through it and figure out what the error was. You spent more time figuring those things out than you did coding it.
Absolutely. Yeah. SQL is it's just a different language, I would say. We probably, like, for our upcoming projects, none of our projects need SQL, but it is extremely important to know for interviews. So we'll end with that. Okay, let me stop the recording and we can get into our check-in. Stop recording. I don't want